Okay, so this problem is asking about the oxidation states of individual atoms within chemical compounds. So first up, we have NaBrO3, and we're asked about the oxidation state of bromine. So we know that oxygen's individual oxidation state is -2. Since we have 3 oxygen atoms, we have to multiply that charge by 3. And sodium, if you remember where it is on the periodic table, it's in the first row, and it's a +1. So to find bromine, we simply just add up the oxidation states. +5 is essentially the oxidation state that bromine needs to have so that the entire compound can have a net oxidation state of 0. Okay? So our next compound is HNO3, and we're asked about the oxidation state of nitrogen. So again, simple, oxygen. -2. We have 3 oxygen atoms. So the net oxidation state of all the oxygen atoms is -6. We have the hydrogen with +1. In our summation, again, nitrogen will also be +5. Alright? In the case of SO3 2-, what this 2- represents is the oxidation state of the entire chemical compound. In the past 2 examples that we saw in parts A and B, the oxidation state of the entire compound was 0. And that's because when you add the total number of positive charges to the total number of negative charges, they balance out and they equal 0. But in this case, they actually equal -2. So total is equal to all of the positive plus all of the negative. But here, if we're given the total, and we actually know the negative in this case because oxygen has the negative oxidation state, we're going to be asked to find the positive, which is sulfur. So how we do this is, we know that oxygen individually is -2, okay? And so what we do is we take the oxidation state of the entire compound, and we subtract the oxidation state of all of the oxygen atoms. And that is how we find the oxidation state of sulfur. Okay? So again, we have C2O4 2-. We know oxygen's oxidation state -2. We multiply by 4. So we take the total of the entire compound, we subtract that of oxygen, and we get +6. But since we have 2 carbon atoms, the oxidation state of each individual carbon atom is +3. There you go.